All right, let's dive right in. Today, we're tackling a really huge idea, a theory called CRET that tries to connect our everyday reality with the, let's be honest, baffling world of quantum mechanics. And it all comes down to something called feedback loops, which might just be the secret operating system for the entire universe.
So that leads us to the big, kind of mind-bending question we're exploring. What if the wave function, that thing you hear about all the time in quantum physics, isn't just a math tool for making predictions? What if it's the actual mechanism of feedback that holds the whole quantum world together?
So here's how we're going to tackle this. Don't worry, we're going to break it all down. We'll start in the world we all know, then jump into the quantum realm, see how the wave function fits into this whole picture, and then finally we'll try to bridge those two worlds and see what it all really means. Okay, let's start with what's familiar, the classical world. You know, the world of cause and effect, where your coffee always gets cold and you can't unscramble an egg. But why? Why does it only go one way? Well, CRET theory says the answer is all about a very specific kind of feedback. The key to all of this is a concept called decoherence. Think of it like this. Imagine a perfectly still pond. That's our pure quantum system. Every little ripple is in perfect sync. Now, decoherence is like throwing a handful of pebbles into that pond. All those interactions with the environment, the pebbles, mess up that perfect harmony. The system loses its special quantumness and starts acting in a predictable, classical way. That disruption, that is the engine of classical feedback.
So here's how that engine actually works. It all starts when a system interacts with its environment. That interaction causes it to lose its quantum coherence. This then kicks off what's called irreversible entropy growth. Basically, things get more and more disordered. And out of all that mess, the one-way street we call the arrow of time just appears. And get this, according to this theory, time isn't even fundamental to the universe. It's just a local side effect of this feedback loop.
And what this theory says is that this process actually creates different layers of reality. You can think of the C layer as, the world of classical things like chairs and planets, and the llama layer as the very geometry of space-time. So even if the universe as a whole is in some timeless, perfectly coherent state, these local layers are where decoherence happens, and that breakdown is what we experience as the forward march of time. Okay, so that's our world, but what about the quantum world? Now we're going deep into a place with a totally different set of rules, a place where feedback does the exact opposite. Instead of creating disorder, it actually maintains perfect order. And here's where it gets really interesting, because the contrast is just stark. You see, classical feedback drives things in one direction, towards disorder, towards losing information. But quantum feedback, it's all about preservation. It sustains a reversible, coherent state where every last bit of information is perfectly kept. It's like two sides of the very same coin. So, in this quantum world, the feedback loops are working overtime to keep everything pristine. They're maintaining the delicate relationships between quantum states, they're upholding the coherence of the entire system, and they allow for a perfectly reversible evolution. This is the world where you can unscramble the egg, so to speak. All of this kind of begs the question, right? What is this quantum feedback? If it's not decoherence, what's making it happen? Well, CRET theory points a finger at one of the most fundamental and honestly mysterious things in all of physics, the wave function itself. And here is the absolute core idea. The wave function isn't just some abstract tool for calculating probabilities. It might be the actual physical embodiment of the universe's global coherence. It's the very thing that holds the entire quantum system together in this one, pristine, interconnected state. The theory pictures this as a kind of multi-layered feedback loop. It all starts at the deepest level, the T layer, which is like the realm of pure, coherent quantum info. This information then feeds upward through entanglement to stitch together the fabric of classical space. That's the C layer. And then it feeds downward as coherent rules that create the geometry of space-time, the lambda layer. It's an incredible, self-sustaining cosmic loop. So what this all boils down to is that the wave function is like the master controller. It's the ultimate constraint that's governing the whole system, making sure that everything evolves together in one massive, unified, and totally reversible quantum state. And that brings us to the real climax of this whole idea. We've got this reversible quantum world run by the wave function, and we've got our irreversible classical world run by decoherence. How in the world do you get from one to the other?
Well, the wild answer is our reality is just an emergent property. The arrow of time isn't fundamental. It's a local illusion that only pops into existence when a tiny piece of that globally coherent quantum system interacts with its environment and breaks down, when it decoheres. It's like we're living inside a tiny localized breakdown of a perfect timeless whole. And this is where it all just clicks into place. What CRET theory is really proposing is this beautiful symmetry. It's a single principle, feedback, that just operates in two totally opposite ways. At the quantum level, it acts as the wave function, preserving perfect, reversible order for the entire universe. But here, at our local classical level, that same principle shows up as decoherence, creating the irreversible flow and the forward march of time that we experience every single day. So let's just pause for a second and think about the profound takeaway here. This offers a completely new way to think about feedback, coherence, and the very nature of time itself. So, to wrap this all up, CRET theory puts forward this incredible idea that our universe at its core is a coherent quantum system. It's sustained by feedback loops that are the wave function. And our messy, classical, time-bound reality, well, it's just what happens when small parts of that perfect system break down and decohere. And that leaves us with one final, just staggering question to ponder. If time as we know it is just a local effect, if it's an emergent property instead of a fundamental part of the universe, what does that truly mean for the difference between our past, our present, and our future? Something to think about. Thanks for joining me for this explainer.